last topic we had done was ester. So what are esters?
They are the sweet-smelling compounds made
Yeah,
by the
they
formation
are
of alcohols and ethanoic acids.
okay. They are sweet, fruity smelling substances. Sweet, fruity smelling substances. Okay. So how they are formed? They are formed by reaction of carboxylic acids. Okay, so till I'm writing the definition, everyone will write down the equation for the formation of ester. Manan, Mehak, Monish, everyone write down the equation. Let's see if you are able to write down the equation. Carboxylic acids with alcohols okay. So once you are done with the reaction, you are supposed to show any of the esterification reactions. Yeah, Manan, have you done? Who all have done? They can show their answers. They can show
So
the
the
reaction.
reactions, right, sir?
Yeah, reaction. You have to write the reaction. Srilasya, have you done?
Done, sir.
Medha Ansini, Srilasya, Saryu, have you completed the reactions?
Sir, I joined just now, sir. What are we supposed to write?
You are supposed to write the esterification reaction.
Okay, sir.
Okay. Manan? Manan?
Sir, can you see mine, sir?
Yes, sir.
Manan, what do we use as the reaction intermediate? What do we use an extra substance over here?
Sir, sulfuric acid,
Sulfuric acid. Which one? Concentrated or dilute?
concentrated.
Okay. Srilasa, show yours. Oh, sorry. Shreyasi, show yours.
Yes, sir.
Sir, can I show?
Okay, CH3. Okay, it's correct. And you
Yes.
also write the symbol heat. It is heated. So also write
Right,
heat.
sir, yes.
Sir, can I show?
Yeah, Srilasya. Very good. Ethyl ethanoate. Okay, that's good. Good, Srilasya. Okay, and your Mehak is showing Mehak. Okay. Yeah, Mehak. Okay, very good, Mehak. Very good. So I think almost everyone has shown. Vedika is showing. Okay, Vedika, Also there, write concentrated H2SO4 on the arrow. Also write down concentrated H2SO4.
Yes, sir.
Okay, are you ready? C2H5OH. Okay, it's correct. So, Monish. Okay, Monish. So I think everyone has understood about the esterification reaction. It is the reaction between a carboxylic acid and an alcohol to produce a sweet fruit smelling substances. And we have seen various examples of this, like rasna, all the juices that we see in the market. They are produced as a result of esters. The smell that they give, that is due to esters. Okay, so that is used in them. Mainly esters are used for the smell that is produced. So sweet, we did this reaction thus CH3COOH, that was ethanoic acid, plus it was C2H5OH in the presence of concentrated H2SO4, and it was heated. So you have to heat it. You obtain CH3COO C2H5 plus H2O. So here, concentrated H2SO4, it acts as a dehydrating agent. It removes a molecule of water from it. Okay. It removes a molecule of water from it, OH from here and H from here. So in this way, it is able to remove a molecule of water. Concentrated H2SO4, it is a dehydrating agent. So it removes a molecule of water from it and hence giving us the esters, the required esters. Now there is just an opposite reaction for this, that is a saponification reaction. Okay. Saponification reaction. Why we call it as a saponification reaction, I will tell you. But see, the saponification reaction, it is just the opposite of this. It is just the opposite of this esterification reaction. Like in the esterification reaction, you have the formation of an ester, right? So you have here ester, and if this ester is reacted with a concentrated sodium hydroxide, like a base, if CH3COO-C2H5 is treated with a base, so you will obtain a sodium salt of the acid will be obtained. Okay. So generally, we write this reaction, it is called as the reverse of this esterification reaction, that it can be reversed by using a concentrated NaOH. Okay. But we write this reaction with this CH3COOH. This is a fatty acid. If it reacts with NaOH, okay. So NaOH, it is also called as caustic soda. Caustic soda or sodium hydroxide, and you will have here formation of CH3COONA plus you will have formation of water molecule. So this reaction is the saponification reaction. The esterification reaction, it takes place. So this is the salt that we have obtained. We call it as the sodium salt of the acid, right? Understand this. Here we have taken a very simple acid, that is ethanoic acid. Okay. Ethanoic acid is a very simple acid that we have taken over here. So ethanoic acid, when reacts with sodium hydroxide or caustic soda, it gives you CH3COONA, which is the sodium salt of the acid or ethanoic acid. Its name is sodium ethanoate. So can anyone guess why do we call it as a saponification reaction? Anyone has any idea why we call this reaction to be a saponification reaction? No one? So to understand this, why do we call it as a saponification reaction? First, we look about the soaps. So what are soaps?
They are mild bases.
They are mild bases. Okay, you can call them as mild bases, but all the soaps, they are chemically either sodium or
And potassium salts.
potassium salts. Okay. So all the soaps, they are either sodium or potassium salts of long chain fatty acids. They are sodium or potassium salts of long chain fatty acids. Okay. The long chain fatty acids here we are saying, see here in this example, we obtained a sodium salt. That is also sodium salt. See, CH3COONA. This is also a sodium salt of a fatty acid. And its name is sodium ethanoate. This is the sodium salt of ethanoic acid. Okay. But if this is not generally salt. Generally, we do not use it as a salt. For a salt, there should be a long chain of carbon like this. You should have a long chain of carbon, and at the one end, you should have like this COONA.
Is this
So,
reaction used in making soaps?
yeah, so that means soaps, this soap, this is what is chemically similar to this only. The only difference is that soap molecule, it has a long chain fatty acid. Okay. This is the long chain fatty acid. Okay. But in this reaction, we have taken, just to understand the concept, we have taken a small molecule. Okay. So you will be writing this small molecule only. However, it can be extended to larger molecules also. Okay. So this is sodium salt of fatty acid. Okay. So understood why we call this a reaction as a saponification reaction? Because in this reaction, there is formation of a soap. And where is the soap? Medha, answer me, which one is the soap out of it?
Sir?
Yeah,
Sir, I don't know, sir.
you don't know. Okay, Mehak,
Yes, sir.
which one is the soap here?
Sir, is it sodium ethanol?
Yeah, sodium ethanoate is the soap. Okay, sodium ethanoate is the soap. They are the sodium salts of long chain fatty acids. Okay, so such a reaction, it can be used for the formation of soap. Hence, we call this reaction as a saponification reaction. So both the reactions are important, the saponification reaction and the esterification reaction, and they are just the opposite of each other. Okay, opposite of each other in the sense, even with the ester, you can do this reaction even with an ester. Okay, if you add to this ester like here, I have taken a soap. Instead, if I do the reaction like this, I do it like this: CH3 COO C2H5. So what is this CH3CO C2H5? Srilasya, what is this? Ester? Okay, the ester which was formed. And now if I add to this ester, if I add NaOH, caustic soda, so I will get here the product CH3COONA plus I will get C2H5OH. Okay, so we can say that the saponification reaction is the reverse of esterification reaction.
Sir, what was
Hmm?
the earlier? So, what was the earlier reaction you have written down? I was unable to note it down completely.
Early on this one, okay, just 1 minute, 1 minute, 1 minute.
Thank you, sir. Yes, sir, I have noted it down.
So when you are asked about the saponification reaction, you can either write this one, or if you remember this, so this is the saponification reaction. A better example or a good one, if you want to write, so this is the saponification reaction. Okay. So if
Yes,
you
sir.
ask the saponification reaction, this is when an ester is combining with sodium hydroxide, you will get the sodium salt of the acid. So the sodium salt of the acid is the soup. Okay. So for preparing the soup, generally long chains are taken like C17H35COOH, that is taken up to make the soup. Long chains are taken, generally 17 to 35, uh, a chain of 17 to 35 carbon atoms is taken for the preparation of soup.
Yes, sir. So it's even more than that, right, sir?
Yeah, even no, generally it lies between 17 to 35. If you move to around 100 of the carbon chain, a carbon chain of 100 atoms, that's generally petroleum.
Oh, okay, sir.
So your petrol or diesel, they generally contain carbon of 100 chains, hundreds of carbon. Now see, okay, one more thing I want to ask anyone. Is there anyone who has studied about the soaps and detergents in detail in the class? In detail means the working action of the soaps and detergents. Anyone has studied the working action?
Yes, sir.
Okay, you have studied. Anyone else? As this part is deleted from the syllabus, so that is why I am asking if you have been taught.
Little
So
bit,
that,
sir.
Sir, our chapter is over. So ma'am taught us this.
Yes, sir.
you forgot, that's a different thing. As see this, that part has been deleted from the syllabus.
But it's there for a question, sir.
Uh, you got questions? Okay, so let's see. The working action of the soaps and detergents. We'll also see the difference between soaps and detergents. Okay, but before that, if you check out the syllabus, in the syllabus that portion is removed. That's no more there. Okay. The working action of the soaps and detergents, it's not there. So how the soaps and detergents work? Let's see. Working of soap and detergents. Soaps and detergents, they are almost the same with a very little difference between them. Okay. And the difference is that soaps are the sodium salts of fatty acids. Just we had discussed that what is a soap? Soap are sodium or potassium salts of long chain fatty acids, whereas detergents are ammonium salts of fatty acids. So the detergents, they are ammonium salts of fatty acids. long chain fatty acids. So how does a soap work? We'll see how a soap works over here. Working action of soap. So just discuss the soaps and detergents. They are long chain. So a long chain is generally represented like this. This is the representation. Okay. So this is the representation of a long chain of carbon, where we assume that at each of these corners we have a carbon atom. Okay. So in this way, this is a long chain of carbon atoms with at one end you have sodium. Okay. So we have just drawn the diagram of a soap or detergent, which is a long chain of carbon atom with sodium at one of its end. Okay. So now the end which there are two ends. As you can see, the soap molecule is having two ends. One end is the sodium, and the other end, at the other end you have carbon. So the end where you have carbon, that end is hydrophobic in nature. This end is hydrophobic. Monish, what do we mean by hydrophobic?
So water repellent, I guess.
Water repellent. Okay. So this end of the chain is water repellent, whereas the end which is sodium, which has the sodium, is hydrophilic in nature. Hydrophilic. Hydrophilic means it will get attracted towards water. Like if you dissolve sodium salt, sodium chloride in water, it will get dissolved. Okay. So sodium chloride dissolves in water as it is water loving. So in the similar way, this sodium, the end which has sodium, it is hydrophilic in nature. It gets attracted towards water, whereas the other end, it moves away from water. Okay. So if suppose we take a fabric, and on the fabric you have a dirt particle. Okay. So on a fabric, if there is a dirt particle, so all the dirt particles, they are oily in nature, right? The nature of the dirt particles is oily. So this is the fabric, and on the fabric you may have a dirt particle. Let's say this is the dirt particle. Okay. So all the dirt particles are oily in nature. So what happened? How does a soap or a detergent work? So we make a solution of a detergent. Fine. We make a solution of a detergent, and in that solution of detergent, first a solution of a detergent is made, and in that solution of the detergent, the cloth is dissolved. Okay. So in the solution, you have these molecules, right? In the solution, you have these molecules whose one end is hydrophobic. So one end is moving away from water, but in the solution, you have water everywhere. Okay. And when you immerse your clothes, so on the clothes, these molecules, they find certain sites which are oily in nature. Okay. And those sites are the sites of dirt. Right. So they attach to the sides of dirt like this. Okay. So the hydrophobic end is attached towards the dirt, and the hydrophilic end is attached to the water. So you understand how it gets attached? The Rene, Rene,
Yes, sir.
okay, how does a soap molecule work?
So the soap molecule,
Yeah, how does a soap molecule work?
uh, the soap molecule, I don't know how to explain it.
Yeah, you know, but you don't know how to explain it. Okay, first explain the structure of soap molecule.
So the structure of soap molecules are like uh, they're like very they're like a tail kind of a thing, like for how you did for C and like carbon and sodium.
The soap molecule has two ends. Okay, one end of the soap molecule is hydrophobic in nature,
And
and
the
the
other
other
end
end
is hydrophilic.
hydrophilic in nature. When we form a solution of soap or a detergent, so the hydrophilic end attaches itself to water molecules. And when the clothes, dirty clothes are dissolved in it, so the dirt on the fabric is oily in nature, and hence the hydrophobic end attaches itself to the dirt molecule. Okay. So the hydrophobic end is attached dirt molecule, and hydrophilic end is attached to the water molecule. Okay. Now, when you agitate the clothes, so this will lead to some forces between them. Okay. So due to agitation, when you are agitating, that means shaking those clothes. Okay. So when you agitate the cloth, the molecule is bound to both the ends. Okay. The molecule is bound to the dirt and the molecule is bound to water also. It cannot leave the dirt and it cannot leave the water. So what will happen? The dirt will leave the fabric. Okay. As the molecule will remain with water, it cannot leave water, and the other is attached to the dirt. So therefore, when you agitate it, the dirt molecule will get removed from the fabric.
Yes, sir.
Okay. So everyone has understood.
Yes, understood.
And this structure which is formed where the hydrophobic end has attached with the soap molecule, attached with the dirt, and the hydrophilic end has attached itself with water. So such structures are called micelles. So
Sir,
what
what
are
is the correct pronunciation, sir? My teacher says it's miscellaneous and you say it's missales.
correct pronunciation? Okay, obviously I will tell myself to be correct. Okay, and if you are saying that it's miscellaneous, so I will search for its pronunciation.
Yes, sir. Because like when I also say missales only, sir.
Okay. So even I have heard from my teacher as missile, and I'm also pronouncing it as missiles. Okay. I've also heard it also missiles many times. So if like missiles, so I'll check it out if it is missiles.
Yes, sir.
So can you once again repeat the definition of missiles?
Missiles. These are the structures formed. These are structures formed when these are the structures formed the soap molecule when the soap molecule attaches when the soap molecule itself attaches itself with dirt and water attaches itself with dirt and water.
Sir, I checked the pronunciation and it's known as micelles.
Micelles.
Yes, sir.
Okay, so how do you get that pronunciation?
Sir, I searched in Google.
Searched in Google. Okay, let me. Okay, it's not micelles. It's not myself. That's not the pronunciation.
Myself.
Okay, so it says myself. Okay, I'll check it out in the thesaurus, how it's pronounced. Okay, the thesaurus is considered the correct one. So I'll check it out with it. Okay, no issues. I think we have done up with the soaps and detergents. Now there is a small topic with it. With the soap, there is a small topic that is formation of scum. And formation of scum, it happens when there is when soaps are dissolved in hard water.
So what do you exactly
So
mean
when
by
soaps
hard
are
water?
dissolved in hard, yeah,
What do you exactly mean by hard water?
hard water. Okay. The hard water is the water which has some salts dissolved in it.
Okay, sir.
Okay. Water that has salts like salts of salts dissolved in it, let's say. Okay. Those salts, they are generally carbonates or hydrogen carbonates. Generally carbonates or hydrogen carbonates.
Like calcium and magnesium, right, sir?
They can be sodium, they can be calcium salts, they can be magnesium salts. Okay. Now it depends that which type of salt is present. On that basis, we say that the soap water has a permanent hardness or it has a temporary hardness. Okay. But that is beyond the syllabus. It's not in the syllabus. So don't go into the depth. Just understand that the hard water is the water that has some salts dissolved in it, and it will not give you good lather with the soap. If you use it with the soap, it will not give good lather. So if since nowadays everyone is using that RO for the purified water, we are using that RO. So the work of that RO is to remove these dissolved salts from water. All these dissolved salts which are present in water, they are removed from it. So what is scum? When soaps are dissolved in hard water, so some insoluble substances are formed. Insoluble substances are formed that float on the surface, that float on water. Okay. So they are called as scum. Here actually there is a wastage of soap. You are wasting the soap. You are not obtaining the leather. Rather that soap is reacting with the hard water to form those insoluble substances. Okay. So those insoluble substances are called as scum.
Sir, can you give example for scum?
Example for scum. There is no example for scum. You can see the picture. I think I'll find out some picture and show it to you.
Sir, is it like that white color particles left after like we bath?
Uh, yeah, similar to that.
Yes,
Scum.
sir.
Let's see scum images. Then we can. I hope you can see. See, these are the particles which have been formed. Can this? Sorry, scum soap. Okay. See, when the soap has been dissolved, you see here some of the white particles which have been formed.
Sir, so it's basically foam.
No, not the foam. Foam is not. That foam you see, that is called as lather. Okay. And if you use that soap with hard water, you will not get foam. You will not get that foam or lather. Let's see. I don't see any such picture which can give you a good Image. Okay. No, I don't see any such pictures. You can try to Google out some of the solid substances. Like this one here, they say.
Sir, you search scum in water, sir.
Okay, so let's see. I think we have finished the chapter. We should move on to question answers then, okay? Soups come in water. You can do it on your own.
The first one, yes, right, sir.
Okay, if you observe this, so maybe okay, you see these solid particles which have been formed, white substances they have been formed. They are the scum. So okay, now let's move to this question answers of this chapter. And one more thing, we have left out one thing that is oxidation reactions and also reaction with metals, reaction of ethanol and ethanoic acid with metals. So if you take ethanol like C2H5OH and react it with sodium, so sodium just displaces this hydrogen from its place. It will form C2H5ONA, which is sodium ethoxide. And there will be liberation of hydrogen gas. Along with it, hydrogen gas will be liberated out of it. In the similar way, just we saw its reaction. If it reacts with acetic acid, then also it will be the same thing. Then also, if it reacts with acetic acid, CH3COOH plus Na, so you will have the formation of CH3COONA plus hydrogen gas will be liberated. Another thing that is there, combustion reaction. Combustion reactions. As we know that combustion means burning in presence of oxygen. Okay. So all these alkanes, alkenes, and alkynes and their functional group, when burnt in presence of oxygen, they will give carbon dioxide and water. So that means if you are burning this C2H4 in presence of oxygen, if you burn this in presence of oxygen, so you will get carbon dioxide and water. If you burn ethanol, C2H5OH, in oxygen, so this will also give you carbon dioxide and water. Okay. If you burn butane, C4H10 is butane. So butane when burnt in presence of oxygen, what will it give? What will be the end product? Finally, what we will get?
CO2 and H2.
CO2 and H2O. Where do we use
Heat
this
and light.
gas? Yeah, where we will get this gas?
LPG.
LPG. The LPG uses butane gas. The main constituent of the LPG is butane gas. Okay. Okay. And also see the difference between the reaction of alkanes and alkenes. If you have any alkanes, alkanes react with oxygen. Alkenes react with oxygen. Okay. So here alkanes will react with oxygen to form again carbon dioxide plus water. Alkenes or alkynes, they will also react with oxygen to form carbon dioxide and water. But here in this case, they require a more amount of oxygen. If you burn them in the atmospheric oxygen, so you will get here black and sooty flame. Black and sooty flame will be obtained. Okay. Now let's see question answers quickly. Okay. Can anyone spot the page number of the question answers? It's there, I think.
It's there only, sir.
So see the first one. I think we have done these questions. No. Okay. Ethane
No,
with the
sir.
molecular formula C2H6. So how many covalent bonds are there?
So 7.
7 covalent bonds, sir.
6 with hydrogen and 1 in the carbon. So 7 covalent bonds. Butanol is a 4 carbon compound with the functional group. So which functional group is present in butanol?
Ketones.
Ketone. Okay. While cooking, if the bottom of the vessel is getting blackened on the outside, it means that
The
so
fuel
what
is
does it mean?
Not burning completely.
Yeah, it means that the fuel is not burning completely. Why it means that? As see, the fuel contains carbon, okay, and that carbon is black in color. So some part of it is getting burnt, and what is left out is carbon. Like from C4H10, the hydrogen is getting burnt out, but the carbon is left out over there. So the carbon is left. That's why it gives you black color. So it means the fuel is not burning completely. Have your option B. Then explain the nature of the covalent bonds using the bond formation of CH3Cl. Okay. So make the structure of CH3Cl.
Done, sir.
Then so CH3Cl CH3Cl, it's represented like this: hydrogen, 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 and chlorine. So explain the nature of the covalent bonds. So what is the nature of the covalent bond?
That it forms single bonds with three hydrogen atoms and one single bond with chlorine atom.
Yeah, so all the bonds are single bonded.
Yes, sir.
Okay. So I think you can draw all the ethanoic acid, H2S, propanol, and F2.
Yes, sir.
Yes, sir. Yes.
Now, what are homologous series?
Sir, the series of compounds which have the same functional groups.
No.
Can I say so?
Yes.
It is a series in which the carbon compounds are of one family, that is like of one series. For example, alkanes, and alkynes. They have
Okay.
their own family of compounds for
Hmm.
having their own general formula.
Okay.
They
So
have same chemical properties.
the family of the carbon compounds having similar chemical properties and where each member is separated by CH2 group.
Right, so yes, sir, I missed that point, sir.
So a family of hydrocarbons having similar formula, having similar chemical properties, where every successive member differ by a CH2 group. Every successive member differ by CH2 group. Then how can ethanol and ethanoic acid be differentiated on the basis of their physical and chemical properties?
Sir,
On the
one thing is that ethanol has its freezing point is at room temperature, and ethanoic acid is at 17 degrees Celsius.
they can be separated out or they can be differentiated on the basis of their boiling point. They can be differentiated
Melting point also.
Sir,
on the
even
basis of
smell is different, sir.
yes,
So their smell, ethanol has like a,
yes. With the smell, ethanol has an alcoholic smell.
It has a pleasant smell, yes.
has a pleasant smell, and
No,
ethanoic acid has a
ethanol does not have a pleasant smell. That's alcoholic smell. We call that alcoholic smell. And alcoholic smell is not pleasant smell.
Okay, so yes. Sir,
Okay.
and sir, ethanol has a burning taste, and ethanoic acid has a sour taste.
Okay, we are okay. Anyways, but we will not taste that.
Yeah, right, sir.
Okay, no tasting. So here, okay, how we will differentiate them on the basis of their chemical properties?
Sir, ethanol does not react with sodium hydrogen carbonate.
Or any bicarbonates.
Okay, ethanol does not react with any bicarbonates, whereas ethanoic acid reacts with the bicarbonates.
And carbonates, yes.
So why does micelle formation take place when soap is added to water?
So because of the dust particles.
No, there
Due
is
to
no
its
dust part.
ionic end and long hydrocarbon and long chains.
Yes, because of its long chain and eh, two ends being hydrophobic and hydrophilic. Because one of the end is hydrophobic and one of the end is hydrophilic. So there is the formation of micelle. Will a micelle be formed in other solvents such as ethanol also?
no, sir, because the hydrophilic end is soluble in alcohol.
Okay. Then why are carbon and its compounds used as fuels for most applications?
Sir, because they give out a lot of heat on combustion. Like whenever the process of combustion takes place, like they give a large amount of heat because of carbon and hydrogen present.
That we call as the calorific value. So here we talk of calorific value. The calorific value of carbon and its compounds is high. Also, it turns out to be clean fuel. Explain the formation of scum, or this you can do. What change will you observe tests? Okay, what change will you observe if you test soap with litmus paper?
It will turn
Sir, it will turn red.
blue to
Turn red to blue.
Sir, it will turn
So-
red to blue.
red
Soaps
litmus
are
to blue
acid.
and blue litmus to blues.
Soaps are acidic or basic?
Blue litmus will remain the same,
The
but red
soaps
litmus
are
will
basic
change.
in nature, so they are mild
Soaps
bases.
are basic.
Soaps are basic in nature. Remember, all the soaps are basic in nature.
Yes, sir.
Okay. So bases turn red litmus to blue. Therefore, soap will turn red litmus to blue. Okay, 13th one. This question number 12 and 13 are important. What is hydrogenation? What is its industrial application? What is hydrogenation? Rene will answer. Rene, what is hydrogenation?
Good.
What is hydrogenation?
So hydrogenation is like I think like when between like molecular hydrogen and like another like compound they like
Manan? Manan, can you tell about hydrogenation?
Molecular hydrogenation.
Okay, Manan, what is hydrogenation reaction? Addition of hydrogen to an unsaturated hydrocarbon. Addition of hydrogen to an unsaturated hydrocarbon is called as hydrogenation reaction. So which of them will go hydrogenation reaction? Sorry, what is its industrial application? So any industrial application of hydrogenation?
Yes, sir. They convert vegetable oils to vanaspati ghee, the dalda.
Yeah, it is used to convert vegetable oils to vanaspati ghee or dalda. Then which of the following hydrocarbons undergo addition reactions? Which of them will?
C3H6.
Okay, C3H6 will undergo addition
And
reaction.
C2H2.
C2H2.
C2H2, as these are unsaturated hydrocarbons. Okay, so this question, these last 3-4 questions, they are quite important. Revise them and best of luck for a test. Do attempt your test, everyone.
So
Okay,
the
bye.
test will end tomorrow, no?
Yes, sir.
Yes,
So the test will end tomorrow, right?
it has started already. You can attempt it.
Thank you, sir. Bye, sir.
Okay, bye.
Thank you, Subhasu.
Okay, bye, everyone.
Thank you, sir.
Thank you, sir. Bye, sir.
Bye.